For today's tutorial, we will discuss on how to calculate the mass matrix for multi-degree of freedom system. So before we go to actual presentation or the today's problem, we will just go through we will revise some basics of multi-degree of freedom system. Now if we have any building of G+2, we want to get the 3 degrees of freedom. So we want to calculate the mass at first floor, second floor and third floor. So our objective is to get the mass at the particular floor level. So entire mass of a building we will concentrate on the 3 point or number of point. So here since we have G+2 building, we will distribute our mass or calculate entire mass at divided it into 3 parts, that is first floor, second floor and third floor. Now this is a basic equation of a motion, mu double dot plus cu plus ku is equal to force. So for this basic equation, u, the displacement factor, is unknown, that is u is unknown, and in order to calculate that displacement we want mass, stiffness and the damping. So all these 3 terms in terms of a matrix. So apart from this 3 term, today we will only focus on the mass matrix. Now today's problem is to generate the mass matrix for the given building. The plan and elevation of building are shown in figure. So here we have building plan which is rectangle in nature, having 3 bays in x direction and 2 bays in y direction, and all the bays are of 5 meter in length, uniform in both the direction, as well as we have 12 number of column which are square in nature, and the floor to floor height of a building is 3 meter. Now apart from this detail, we have grade of concrete as a M25, brick wall thickness as a 230 mm. So for any building we may have different types of a wall. So here we have exterior, interior and parapet wall, but there is no change. All 3 type of wall have the uniform thickness of 230 mm and the height of parapet wall is 1 meter. So the beam cross section given for this problem is 230 mm as a width, 300 mm as a depth, and the column size is square, which is 300 mm by 300 mm. So our today's objective is to generate the mass matrix, where we will calculate this M1, M2 and M3. And suppose if we have more number of degrees of freedom, this is a universal matrix for n degrees of freedom, where we have Mn. So Mi, Mi plus 1, Mi plus 2 and so on, all the diagonal element up to Mn, and the size of element or the matrix will be n is to n. Now in order to consider the live load or a imposed load for calculation of a seismic mass, IAS 1893/2002 have some guideline. So if I look at to the clause number 7.3.1, for various loading cases as specified in IS 875 part 2, the earthquake force shall be calculated for the full dead load plus the percentage of imposed load as given in table 8. Now table 8, what it summarizes, if imposed load is uniform in nature and the intensity is 3 kilonewton per meter square, less than or equal to 3 kilonewton per meter square, we have to consider the 25% of imposed load. Now the same imposed load having intensity more than 3 kilonewton per meter square, we have to consider the 50% of imposed load for seismic mass calculation. The second clause on the same imposed load suggests us to avoid the imposed load on the rooftop for the seismic mass calculation. Now let us discuss how to calculate the mass of a building. Now in order to calculate the mass of an entire building, we will divide it into small component. Now if we divide the building in different component, we will get it as a 4 to 5 main element. Let us recall and list all the elements. First one is a slab, second can be beam, third can be column, and fourth can be infill wall. Though we have fifth one also as a footing, but since footing will be under the ground and it will not shake, so it will not comes under the seismic mass. So we will focus on 4 element. Now let us calculate the mass of a slab. Now here we can see that mass of slab is nothing but for calculating any mass we need to multiply the volume into density. Here we have 15 meter in x direction, 10 meter in y direction. So we will write it down, 15 multiply by 10 multiply by thickness of slab. So this is the volume. Density is nothing but 25 kilonewton per meter cube. This is the density of a concrete. Multiply by 10 raised to 3 divided by 9.81. This will give us the mass of a slab as 45,871.56 kg. Now let us move to the beam. Now beam is the element which supports the slab, and generally we provide beam just below the walls. Now since we provide beam just below the walls, it will be run throughout the floor. So here if we look at the diagram, we have beam at the periphery as well as inside the building. The way we have calculated the mass of a slab, similarly mass of beam will be nothing but the, first of all we have to calculate the volume. So for one beam it is 0.23 is a cross section, 0.3 is a depth, multiply by length. Now here length is, let us consider entire length. So first of all we will, this is the 15 meter is a length in x direction. So 15 into 3 plus 10 into 4 is a length. So this will give us, this product will give us the volume, multiply by 25 into 10 raised to 3 divided by 9.81. So this will give us the 14,946.48 kg as a mass of a beam. Now let us move to the column. Now column is the element, structural element which support the beam. So it will generally at the end of a or at the intersection of a various beam. So here if we look at the diagram, we have square column at all the junctions. So if we count it 1, 2 up to the 12, and the cross section of column is 0.3 by 0.3. Also the height of floor to floor height of a column is 3 meter. So let us calculate the mass of a column, which is nothing but the 0.3 by 0.3 is a cross section, multiply by height, multiply by density, divided by 9.81 will give me the total mass as 8,256.88 kg. So this is the column. Now similarly for wall. So wall, here we have two type of wall, interior, exterior as well as parapet. Now interior, exterior can be clubbed as a one because they have same thickness, but height of exterior interior wall and the height of parapet wall are different. So we will consider this wall, we will calculate mass of these two walls separately. Let us calculate the mass of all exterior and interior wall. So the total mass of wall is nothing but the 0.23 is a thickness. Now 3 meter is a height, but apart from 3 meter height, suppose we have, this is a beam of 0.3 meter. So wall will be only up to 2.7 meter height for all infill panel. So hence we will deduct the beam depth from the total height, and then the way we have calculated the length of a beam, same will be the length of a wall. So 15 into 3 plus 10 into 4. So one is for x direction, another one is for y direction, multiply by, now here the density of a wall will be 20 kilonewton per meter cube. So 10 raised to 3 divided by 9.81 will give us the total mass as a 1,07,614.68 kg. So this is the mass of a wall. These walls are interior and exterior. Now if we calculate the parapet wall mass, it is nothing but the 0.3 thickness. Now here on rooftop we don't have anything, so it will be height of wall will be 1 meter into length. So as we know, parapet wall is provided for protection, which will be at the periphery. So the length will be perimeter 15 plus 10, this is the length, and again density 20 into 10 raised to 3 divided by 9.81 is equal to 23,445.46 kg. So this is the total weight of a parapet wall. We want to get the final calculation of M1, M2 and M3. Now if we assume it very carefully, we can see that typical floor have the same mass, and the top floor it will be having either more or less mass, because if we consider half of the mass from top and from bottom, if we consider half mass, so for top floor we only have parapet wall up to 1 meter on the above floor, whereas on the space between the third floor and second floor we have the half column. So let us see how to calculate the mass of typical floor. So this is it for typical floor. We have entire mass of slab. Suppose this is our building under consideration. We are talking about this one. Now we have to consider the only half. So portion between this one will act as M1, this will as a M2, and above as a M3. So here we are talking about M1 and M2. So total mass of a slab plus half of the column below plus half of the column above. So slab plus half for below floor, half floor above floor, this is for column, here it will be plus entire weight of a wall plus weight of a beam. So it will give us the mass as 176.69 into 10 raised to 3 kg. Now if we calculate the mass of M3, it will have weight or the mass of slab plus half mass of column plus half mass of wall, which is in this area, plus mass of a beam and mass of parapet wall. So sum of all this will give me the total mass on the rooftop, which is nothing but the 136.215 into 10 raised to 3 kg. So this is how we have calculated the mass of first floor, second floor and the third floor, and when we put this into matrix, it will look like M1, M2 and M3. So we are just taking out 10 raised to 3 outside, and all the unit of this one is in kg. First of all, we have calculated the mass of a slab. Now this mass of a slab can be of dead load in nature or live load in nature. So for dead load, the typical process is nothing but to calculate the volume of a slab and then multiply by density. For imposed load, IS 1893 tell us that if the intensity of live load or the imposed load is up to 3 kilonewton per meter square, we have to consider the 25% of mass, and in case of it is more than 3, we have to consider only 50%, and we have to neglect the imposed load on the rooftop. Now once the calculation of mass of a slab is finished, we can go with the beam, after that column, and then at the end for wall. Now wall can be of parapet, interior, exterior. If all of them have same thickness, we can go calculate the mass in a single shot, but parapet we have to calculate it separately because it has a height of 1 meter. And in order to calculate the mass of interior and exterior wall, we have to divide the total from total height of a wall, we have to divide the depth of a beam. So once we do that, we will get the actual mass of a wall between the two floors, and then for corresponding M1 M2, which is nothing but the typical floor, we have to consider the half of the wall load and column load for above and below floor, and for on the rooftop floor we have to consider half of the column and the wall load for below floor, and for top floor we have to consider the parapet wall. Thank you.